lecture by looking at the non-competitive inhibition. So a non-competitive inhibitor, right, different from the competitive inhibitor, right? It does not have a structural resemblance to the substrate. So in terms of the shape or conformation, right, it is not similar to the substrate, and that means that the non-competitive inhibitor is not complementary to the active site of the enzyme. It does not bind to the active site. It binds to somewhere else, a site other than the active site. Okay, so when the non-competitive inhibitor binds to this site other than the active site, it causes a conformation change to the enzyme, which in turn causes the active site to change as well, right? So the active site is no longer complementary to the substrate. It prevents effective coalition and formation of enzyme substrate complex when the non-competitive inhibitor has bound to the site other than the active site. Right, so it is described that the non-competitive inhibitors render a portion of the enzyme out of action, and it decreases the effective enzyme concentration. Right, so what does this mean? Right, let me show you an example. Right, so on the screen you see 9 enzyme molecules, and 2 of them are bound, right, by non-competitive inhibitor. So there are 2 molecules of non-competitive inhibitor, 9 molecules of enzyme. Right, so we call that non-competitive inhibitor is a reversible inhibitor. Right, we mentioned that in the beginning of the lecture. So the enzyme function is restored after the inhibitor dissociates from the enzyme. Right, it is a reversible inhibitor. The non-competitive inhibitor can dissociate pretty rapidly from the enzyme. Right, so once it has dissociated, right, the enzyme molecule would be turned to its original state, right, and it would have restored its function. But after dissociation, right, the non-competitive inhibitor can go on to bind to other enzyme molecules, right, which means at any one time, as you can see here, there would be 2 enzyme molecules that are bound by the non-competitive inhibitor. Right, one more here. Right, at any one time, 2 molecules of enzymes are bound and therefore are inhibited by the 2 non-competitive inhibitor molecules in this example, which means at any one time a portion of the enzyme molecules are inhibited. A portion of the enzyme molecule is rendered out of action by the non-competitive inhibitors. So effectively, the enzyme concentration has decreased, right? Instead of 9 enzyme molecules, only 7 are functional at any one time, so decreasing the effective enzyme concentration. Right, so I hope this example explains these 2 points, right? The rendering of the portion of enzyme of action and decreasing the effective enzyme concentration. Okay, so because the enzyme concentration effectively is lowered, increasing the substrate concentration would not be able to reverse this inhibition. Right? There is basically less enzymes or less functional enzymes. Right? And because there's no competition, right, between the inhibitor and the substrate by binding to the same place, unlike the competitive inhibitor, having more substrate cannot outcompete the inhibitor. The inhibitor will just bind to a site other than the active site. There's nothing blocking or nothing competing with it and preventing it from binding to the enzyme. Right, so increasing substrate concentration would not be able to reverse the inhibition, unlike for competitive inhibition. Right, so for the graph, right, showing the enzyme kinetics with and without the inhibitor, this is what it typically shows. Right, even in high substrate concentration, there is no achievement of the same Vmax as if there is no inhibitor. Right, the rate of reaction, the maximum rate of reaction with the inhibitor would always be lower. Okay, so if you basically draw a graph, right, draw a graph showing the change in the rate of reaction in increasing substrate concentration for a reaction with less enzyme, with a lower enzyme concentration, this is what you get. Right, you will get the graph with the non-competitive inhibitor. It is similar to the graph with a lower enzyme concentration. Alright, because again, the effect of the inhibitor is a decrease in the effective enzyme concentration. Alright, so check your understanding, right? Using the figure of 6.4, right, can you check the values and compare the affinity of the enzyme again? You will find that it's different, right, from between the non-competitive inhibitor and the competitive inhibitor. Alright, so pause the video, spend some time, check the Km, check the affinity. Alright, once you're done, you can resume the video. Okay, so now that you're done, okay, I hope you see that with and without the non-competitive inhibitor, the Km and therefore the affinity of the enzyme is the same. Right, so I have done the working here, so you can check your own working as well. Right, so the Km and the affinity is the same, but the Vmax is lowered, right, in the presence of the non-competitive inhibitor. Why is the affinity not lowered? Right, because again, the effect of the non-competitive inhibitor is basically a decrease in the enzyme concentration. But for the enzyme, right, for each enzyme molecule, as long as it is not bound by the non-competitive inhibitor, it is basically the same enzyme. The affinity, the likelihood of each substrate binding to each enzyme molecule is the same. It's just that overall there are less enzyme molecules that are functional. So that's why the Km and the affinity is the same. Right, but there is a lower Vmax overall in the presence of the non-competitive inhibitor. Right. Okay, so you have a table, right, in the notes for you to do a comparison between the comparative and non-competitive inhibitor. Please do that on your own, and you can check the answer over SRS.